Good morning. In this video, we are doing very important questions of chemical bonding. So let's start without wasting time. Now, these are the very important questions of chemical bonding. Let us start doing. The very first question is out of NH3 and NF3, which has high dipole moment and why? How to write down the answer? C. Out of ammonia and NF3. First of all, you have to draw the structure in its answer. This is for ammonia, pyramidal shape, and this is for fluorine, NF3. So out of these two, nitrogen has high electronegativity. So dipole moment will be in the upward direction. आप क्या लिखेंगे? All the dipoles are in upward direction. Upward direction, and they will be added up to give high value. So ammonia has high dipole moment because all the dipoles are in the upward direction. In case of हाँ बोलो बेटा, बोलो बोलो। और क्या, यही तो करनी है। हाँ ग्रुप में भेजा, सारा वही करना है, ग्रुप वाला ही करना है। ठीक है, चलो। हाँ पूछो 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 बेटा पूछो। In NF3, three dipoles, see, fluorine is having more electronegativity than nitrogen. So three dipoles are in the downward direction and one dipole is in the upward direction. So some cancellation will take place. Three dipoles in downward direction and one dipole in upward direction. So some cancellation will take place. Some cancellation takes place to give the low value. So iska dipole moment will be smaller. Next is, though in BCl3, there are three polar bonds, still its dipole moment is 0. Once again, we have to draw the structure. BCl3 has triangular planar structure. So all these dipoles will cancel out each other. Why? Because of symmetrical structure. So answer is because of symmetrical structure of BCl3, all the dipoles will cancel out each other. Will cancel out each other. Right? This question is also done. Next is, what is the relation between bond order and bond length? They have inverse relation. This is bond order. It is inversely proportional to bond length. Or we can say, higher the bond order, smaller is bond length. Next question. How many types of bonds are present in PCl5, which is longer and why? See the structure of PCl5. This is very important question. PCl5. This is P and these are the Cl, right? Its shape is triangular bipyramidal. One pyramid is in the upward direction, one pyramid is in the downward direction. So its shape is triangular bipyramidal, right? These two bonds, one is this bond, one is this bond. These are known as axial bonds, and these three bonds are known as equatorial. So we can say axial bond is longer than equatorial bond. Why these two bonds are longer? Because they experience more repulsion. Because they experience more repulsion. And higher the repulsion, higher is the bond length, right? So in PCl5, two types of bonds are there. Two more examples are there. One is ClF3. This is also having the same geometry. इसमें भी two types के bonds होते हैं. SF4 इसकी seesaw shape होती है. इसमें भी two types of bond lengths होती हैं, equatorial and axial, equatorial and axial. ClF3 में दो lone pair होते हैं. इसमें भी two types of bonds होते हैं, axial and equatorial. So T shape इसकी shape होती है. All these three examples are very, 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 very important. Okay. So let us move to the next question. Exactly. The same question is there. Draw the shape of SF4 and ClF3. Well, the shape of SF4 is, see, it is just like PCl5, the geometries, but 4 Cl are there. So F, not, sorry, SF4, it's not SCl 4, it is SF4. So 4F will come here, one lone pair. The shape is seesaw and geometry is same, triangular bipyramidal. The whole structure is known as geometry. In SF4, geometry is triangular bipyramidal, but the shape is seesaw. Now, what is the ClF3? In this case, one lone pair, four bond pairs. In ClF3, see, once again, the geometry is same and fluorine will occupy these three positions and these two are occupied by the two lone pairs. So this is having two lone pairs and T shape. Is this bond angle 90 degree? No, it is slightly less than 90 degree because of these two goons. They will repel this bond pair, right? So T shape, two lone pairs and two types of bond lengths are there, just like PCl5. Okay. Next is how many lone pair and bond pairs are there? Also bond angles. Bond angle in this is the bond angle 120 degree and this bond is of 90 degree, right? In this case, two bond lengths are there and they are less than 90 degree. Okay. Next is question number 6. Why ionic solids are bad conductors in solid state? Because ions are tightly held and not free to move about. That's why they are bad conductor and not free to move about. Next, will the type of hybridization change in the following? BF3, its hybridization is sp2. Ammonia has sp3. And after making bond, ammonia will remain same as sp3, but BF3 boron's hybridization will change. It will become sp3. AlCl3 has hybridization sp2 and this AlCl4 1 negative is having sp3. Yes, hybridization will change. Next question is, right, 8. Why bond angle in ammonia is more than that in water, though both have distorted tetrahedral? See the answer. The question is, let me explain its structure first of all. Oxygen has two lone pairs and two bond pairs. It has three bond pairs and one lone pair. The question is its bond angle is 107 degree. Its bond angle is 104.5 degree. The question is both of these are distorted tetrahedral, but its bond angle is lesser than that of 107 by. The very first answer is ammonia has one lone pair of electron, but in water, two lone pair of electrons are there. What else? In these three repulsions are there. Lone pair. In water, lone pair repulsion. More than lone pair bond pair repulsion. More than bond pair repulsion. But in this case, only two repulsions are there. Lone pair bond pair. More than bond pair. Right? So this is the answer. No doubt both of these are distorted tetrahedral, but because of the presence of two lone pairs in water, its bond angle is lesser than that of ammonia, which is having only one lone pair of electron, right? Next question. Write the important aspects of resonance with example CO3 to negative. Well, this is the structure of carbonate. Its resonating structure is, this will become single bond, double bond will move here, and the third structure double bond will come here, and these are the resonating structures of this. We can label these structures 1 2 3, and the resonance hybrid structure is having this kind of structure. The double bond is present or rotating between all these bonds, having two negative. Important aspects means, see, in all these resonating structures, the relative position of atoms is same. Only the distribution of electron is different. One point is the relative positions of atom is same. They differ in the distribution of electrons only. Resonating structures have no real existence. This is the third point. Resonating structures have no real existence. And resonance hybrid is the real structure. These aspects can be written only, right? Relative position of atom is same. These differ in the distribution of electrons only. Resonance is shown by doubly-headed arrow, and resonating structures have no real existence. And resonance hybrid structure is the real structure of that compound. Okay. Next is 10th question. Although both CO2 and water are triatomic, means both of these are made up of three atoms. The shape of water molecule is bent while that of CO2 is linear. Explain this on the basis of dipole moment. See, in carbon dioxide, no lone pair of electron is there. Its dipole moment is zero. If zero dipole moment is there, the structure will be symmetrical, that is linear. But in case of water, because of presence of two lone pair of electrons, the structure is bent and dipole moment is not zero. So what is the main answer? It is not having any lone pair of electron. So dipole moment is zero. In water, the structure is bent because of presence of two lone pair of electrons and dipole moment is not zero. Okay, zero, not zero, no lone pair, two lone pair. That's why linear and bent. Next question is, arrange the bonds in order of increasing ionic character in the molecule. सबसे ज़्यादा ionic character will be of the less most electronegative and less electropositive. C means electropositive character नीचे वाला होना चाहिए. Lithium is not basically making ionic bond. In metals जो upper वाला atom होता है that will make only covalent bonding, नीचे वाला will make ionic because उसकी IE कम होती है, right? So let me clear all the drawings first of all. Okay, in question number 11, arrange the bonds in order of increasing ionic character. K2O is ionic, LiF is also ionic. Out of these two, K2O is more ionic because normally lithium makes covalent bonding, right? Now, out of SO2 and ClF3, their electronegativity difference is more. So it will be ClF3, then SO2, then N2, right? You have to put the less than symbols. What is meant by hybridization of atomic orbital? Describe the shapes of sp, sp2, sp3 hybrid orbitals. So here you have to write down the definition. See, hybridization is intermixing of orbitals of same atom having slightly different energies so that redistribution of energy may take place to make equal number of orbitals with the same shape and size. Shape and size. It is the intermixing. किसकी? ऑर्बिटल्स की. कौन से? सेम एटम की. वाई? क्योंकि उनकी स्लाइटली डिफरेंट एनर्जी थी. तो क्या होगा? रीडिस्ट्रीब्यूशन हो जाएगा एनर्जी का, मिक्सिंग हो जाएगी, सब एक दूसरे की ले लेंगे ताकि बराबर हो जाए. टू मेक द इक्वल नंबर ऑफ ऑर्बिटल, ऑफ कोर्स अगर दो कंबाइन दो करेंगे इंटरमिक्स तो दो ही बनेंगे ना, कुछ भी नष्ट नहीं होता है. नंबर ऑफ ऑर्बिटल विद द सेम शेप एंड साइज. नाउ व्हाट इज sp hybridization? When one s combines with intermixes with one p, then two are formed, big lobe and small lobe. This is one hybrid orbital. This is second hybrid orbital. So S and P combine to make two orbitals and linear shape and 180-degree ka bond angle, right? sp2 hybridization 1s and 2p will intermix to give 3. One is the bigger lobe, smaller lobe, bigger, smaller, bigger, smaller. And hybridization sp2 it will be, and a triangular planar shape and 120-degree का bond angle होगा. ठीक है. नेक्स्ट है sp3. sp3 में क्या होगा? 1s होगा and 3p orbitals, they will intermix to make 4 orbital and their shape will be like this. On the line, you have to draw the big lobe, big, small, and big, small, right? So this is sp3 hybrid orbitals, and the shape is tetrahedral, and the bond angle is 109 degree, 28 minutes. Okay, write down with me. You can pause the video along with. Okay, you can also pause the video while writing. Question number 13 is there now. Draw the diagram showing the formation of a double bond and a triple bond between carbon atoms in C2H4 and C2H2. So let us take first of all the example of C2H4. It is known as ethene or ethylene, right? The basic structure of ethene or ethylene is like this. They are having one double bond, right? This is triangular planar shape. 120-degree ka bond angle will be there. Of course, the hybridization will be sp2. It is quite clear from the structure and angle. So you have to write down the carbon 6, 1s2, 2s2, 2px1, 2py1. And one electron will be shifted from 2s to 2pz. This is known as ground state, and we are going to draw the excited state, right? 1s2, 2s1. One electron will be shifted to 2pz. So hybridization will be sp2. This 2pz orbital will not participate in hybridization. So this carbon, to draw the structure, there is one trick. See how to draw. You have to draw this line first of all, then 2 lines this side, 2 lines this side. Mark the central point. This is a trick to show or draw the structure. So start from here. Big lobe, small, big, small, big, small. This carbon is also there. Overlap it. Big, small, big, small, big, small. Right? Now H will come. They are spherical in shape because their last electron is present in S, and S is spherical in shape. So these H will overlap to make the sigma bond. Sigma, 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 sigma bond. And this is also the sigma bond. Now, we have to draw the structure of pi bond. How to draw? This 2pz orbital was left. Now, this is 2pz orbital, 2pz orbital. They will show sideways overlapping. This is known as pi bond. So, यहाँ पे लिखना है H, H, H. sp2 hybridization should also be there. 120-degree bond angle, and the name of the shape is triangular planar. See, you have to draw the structure, label it, hybridization, bond angle, and name of the shape. Only then you will get marks. Okay. So next is C2H4. C2H4 is, sorry, C2H4 we have done, is known as ethine or acetylene, right? So carbon once again, the ground state. And in the excited state, one electron is shifted from this to 1s2, 2s1, 2px1, 2py1, and 2pz1. C2H2 has this kind of basic structure, the Cooper structure. It is showing two pi bonds, one sigma bond. So hybridization will be sp, no doubt. So you have to show sp hybridization. They will not hybridized. So the type of hybridization is sp. How to draw the structure? Once again, there is a trick. See, this carbon and another carbon, right? You have to show, first of all, these two carbons. This is one carbon. This is another carbon. Two carbons I have shown. They are making one sigma bond. Now, hydrogen will make bond with this orbital, sigma bond. These structures I have shown right now. Now, to show the two pi bonds, 2py orbital and 2pz, 2pz will be shown. 2pz and 2pz, they will show sideways overlapping, and y will show with the y overlapping. Label it. It is hydrogen, and these two are carbons. This is sigma bond, and these two are the pi bonds. You have to label also. Linear shape, and the bond angle is 180 degree, right? All these points you have to write down. Next is, which hybrid orbitals are used by carbon atom in the following? Wait. CH3, CH3. There should be single bond. sp3 hybridization, sp3. CH3, this should be the single bond. sp3. Double bond carbon is always sp2, sp2. Single bond, sp3, ch2 also showing single bonds, sp3. We have not to write down the hybridization of any other element other than carbon. CH3, sp3, CHO. In CHO, carbon is always sp2. This is aldehyde group. In acidic group also carbon is showing sp2, and here it is showing sp3. Right? Okay. The question number 15. Use molecular orbital theory to explain why Be2 molecule does not exist. According to molecular orbital theory, let us write down the configuration of beryllium. It is 1s2, 2s2, right? So 1s, let me draw the molecular orbital picture of this. This is 1s, 1s, sigma 1s, sigma star 1s. And this is 2s, this is 2s, 2s, this is sigma 2s, and this is sigma star 2s. This is one beryllium, this is another beryllium. The configuration is 1s2, 2s2. This is also showing the 1s2 and 2s2. So 2 and 2, 4, 2 electrons are here, 2 are here. Out of these 4, 2 will be here and 2 will be here. This is the energy level diagram of beryllium Be2. Now, what is the bond order? To calculate the bond order, formula is half of number of bonding electrons. This is anti-bonding, this is anti-bonding, this is bonding, and this is bonding molecular orbital. In these two bonding molecular orbitals, means we call it Nb minus Na. Half of total bonding electrons are 4 in number, 2 and 2, 4. So 4 minus. Anti-bonding कितने हैं? 2 and 2, 4. 4 minus 4 क्या हो जाएगा? 0. तो answer 0. Now we can say Be2, see the question, Be2 will not exist because its bond order comes out to be 0. This is the answer. You have to show the diagram and write down the bond order. It comes out to be 0 and you will say, yes, it will not exist. Compare the relative stability of molecule species and indicate their magnetic properties. Let me tell you one thing. O2 positive, O2 it should be written here, and O2 negative and O2 2 negative. This is having 15 electron, 8 8 16, और एक माइनस कर दो 15, 16 electrons, 17 electrons, 18 electron. You keep in mind always bond order for 15 electron is always 2.5, for 16 2, for 17 1.5, and for 18 it is 1, right? O2 is paramagnetic. O2 plus is also paramagnetic. Why? Because it has two unpaired electron in the anti-bonding molecular orbital. दो unpaired होते हैं इसमें. ये भी होगा paramagnetic. This will be only diamagnetic, right? So check कर लो magnetic properties का क्या है. What you have to write down? Its bond order is 2, 2.5, 1.5, and 1. Now, how the stability is compared? Higher the bond order means the bond order of O2 positive is the highest or most. जिसका ज्यादा बॉन्ड ऑर्डर होगा उसकी स्टेबिलिटी ज्यादा होगी. तो हम क्या लिखेंगे? O2 positive is more stable than O2, more stable than O2 negative, more stable than O2 2 negative. And what is the meaning of magnetic properties? You have to write down it is paramagnetic, it is para, it is para, it is diamagnetic. This is known as magnetic properties. Okay. Next, what is the meant by bond order? Bond order का मतलब ये होता है half of Nb minus Na, number of bonding electrons, minus number of anti-bonding electrons, उसको bond order कहते हैं. ठीक है. कैलकुलेट द बॉन्ड ऑर्डर ऑफ N2 O2 O2 पॉजिटिव एंड O2 नेगेटिव. अब इसमें दो बातें हैं. एक आप एनर्जी लेवल डायग्राम से भी दिखा सकते हो. अगर आपको याद है तो वो भी लिख सकते हो आप कितने बॉन्डिंग कितने एंटी बॉन्डिंग होते हैं. मैं दोनों का बना देती हूँ, नाइट्रोजन का भी ऑक्सीजन का भी, और आपको आसानी हो जाएगी. ठीक है. देखो मैं पी वाला बना रही हूँ खाली. एस वाला तो जैसे बेरिलियम का बनाया था ना नीचे, सेम बनेगा बेरिलियम का दोनों का. मैं पहले इधर नाइट्रोजन बना देती हूँ. ये मैं नाइट्रोजन का बना रही हूँ. नीचे वाला सेम रहेगा, मैं बोल रही हूँ पहले भी. आप चाहो तो स्क्वायर से भी दिखा सकते हो, कोई इश्यू नहीं है, कोई बड़ी बात नहीं है ये. नाइट्रोजन में ये 1 1 1 इलेक्ट्रॉन होते हैं. 2p(x1), 2p(y1), 2p(z1), लाइक दिस. 3 and 3 6 हो गए. 2 यहाँ पे आएंगे, यहाँ पे आएंगे. इसको बोलते हैं पाई 2p(x), इसको बोलते हैं पाई 2p(y), इसको सिग्मा 2p(z). ऊपर वाले खाली पड़े हुए हैं सारे. इसको बोलते हैं एंटी बॉन्डिंग, यानी कि पाई स्टार, इसको भी पाई स्टार, इसको सिग्मा स्टार 2p(z) बोलते हैं. ठीक है. सिग्मा स्टार. ये बॉन्डिंग ऑर्बिटल्स हैं, ये एंटी बॉन्डिंग ऑर्बिटल्स होते हैं. सो बॉन्ड ऑर्डर का फॉर्मूला होता है हाफ ऑफ बॉन्डिंग इलेक्ट्रॉन. ये बॉन्डिंग इलेक्ट्रॉन है 6, 6 बॉन्डिंग इलेक्ट्रॉन नीचे पड़े हुए हैं, माइनस ये ऊपर वाले एंटी बॉन्डिंग 0 है. तो 6/2 कितना आ जाएगा? 3 आ जाएगा. तो ये बॉन्ड ऑर्डर 3 है. 26 क्वेश्चन देखो. ड्रॉ द एनर्जी लेवल डायग्राम ऑफ N2. ये वाला बना देना. लिखना है, यू हैव टू राइट डाउन 2p(x1), 2p(y1), 2p(z1), 2p(x1), 2p(y1), 2p(z1), और ये मैंने शो कर ही दिया कि पाई 2p(x) है नीचे, पाई 2p(y), और यहाँ पे सिग्मा 2p(z), पाई स्टार 2p(x) है ये पाई स्टार 2p(y) है. नीचे वाला जो बेरिलियम का बनाया था ना, वो भी बनेगा नीचे, है ना. क्लास में लिखवाया था, और वैसे भी देख लेना आप उसमें, बुक में देख लेना, एनसीईआरटी की बुक में बना हुआ है. ऑक्सीजन में क्या होता है? ये होता है ऑक्सीजन में. देखो ऑक्सीजन का सीन देखो थोड़ा सा क्या डिफरेंट है उसमें, है ना. एक डिफरेंस तो यही पता चल गया तुम्हें. ये देखो उसमें दो नीचे एक ऊपर है, इसमें एक नीचे दो ऊपर है, लाइक दिस. राइट. 2p(x2) होता है इसमें, 1 इलेक्ट्रॉन इज एक्स्ट्रा, लाइक दिस. ये 1 होगा यहाँ पे. तो 4 and 4 8 होता है. 8 में से 2 यहाँ जाएंगे, 1 1 यहाँ, फिर 1 1 और 6 हो गए. 1 इसमें जाएगा, 1 इसमें जाएगा. इसको बोलते हैं पाई स्टार 2p(x), इसको बोलते हैं पाई स्टार 2p(y), और ये है सिग्मा 2p जेड, और सबसे ऊपर वाला सिग्मा स्टार 2p z। स्टार का मतलब होता है एंटी बॉन्डिंग। और ये होते हैं पाई 2px, जैसे उसमें था नाइट्रोजन में पाई 2px, और इसको बोलते हैं पाई 2py। इसका बॉन्ड ऑर्डर निकालेंगे। हाफ ऑफ बॉन्डिंग कितने हैं, 6, ऊपर कितने हैं, देखो यहाँ पे 2 इलेक्ट्रॉन्स, वहां खाली था ना नाइट्रोजन में, यहाँ पे 2 इलेक्ट्रॉन्स है, तो 4/2 आ जाएगा। इसका बॉन्ड ऑर्डर आ जाएगा 2। ठीक है। बाकी मैंने एक तरीका बताया था, इलेक्ट्रॉन से हम निकाल सकते हैं। देखो नाइट्रोजन का बॉन्ड ऑर्डर 3 है, O2 का 2 है, O2 प्लस का 2.5 है, O2 नेगेटिव का कितना होता है, 1.5। ठीक है। तो इनके ये बॉन्ड ऑर्डर है। आप इससे भी निकाल सकते हो। N2 O2 पॉजिटिव का क्या मतलब होता है, यहां से एक इलेक्ट्रॉन निकाल दो, निकालेंगे तो 6 - 1 हो जाएगा, 5/2। हम इस कॉन्फ़िगरेशन से निकाल सकते हैं फॉर्मूले से। ठीक है। नेक्स्ट है, why HF is liquid but HCl is gas? Because of H bonding in HF बट नॉट इन HCl। फिर वो ये आंसर भी लिख सकते हैं कि HF ही क्यों शो करता है, बिकॉज ऑफ हाई इलेक्ट्रो नेगेटिविटी ऑफ फ्लोरीन एंड इट्स स्मॉलर साइज। These two are the conditions: smaller size and high electronegativity. KHF2 exists because it shows H bonding. It will not show H bonding. Water has high boiling point shows H bonding. It will not show H bonding. Orthonitrophenol has low boiling point than paranitrophenol. See, what is orthonitrophenol? This is phenol. This is ortho position. Here NO2 is written. And what is paranitrophenol? This is phenol. At para position, nitro group is there. They are too close to each other. They will show the bonding like this. इसको बोलते हैं खुद के साथ बॉन्डिंग बनाना, पड़ोसी के साथ नहीं, खुद के साथ। सो वी कॉल इट इंट्रा मॉलिक्यूलर एच बॉन्डिंग। ऐसे बैठे हैं तो आपस में लूज लूज बैठे हुएंगे, बट ये इट विल शो पैरा बॉन्डिंग। एक पैरा नाइट्रोफिनोल दूसरे पैरा नाइट्रोफिनोल के साथ एच बॉन्ड बना लेते हैं, दूसरे का हाथ पकड़ा हुआ है जोर से, तो इसका बॉइलिंग पॉइंट ज्यादा होगा। अब हम ये तो लिखेंगे नहीं हाथ पकड़ा हुआ तो उसने अपना पकड़ा हुआ था, आप कहेंगे इन पैरा नाइट्रोफिनोल देयर इज इंटर मॉलिक्यूलर एच बॉन्डिंग ड्यू टू विच its boiling point is higher। और orthonitrophenol में because of the intramolecular H bonding, the bond with the neighbor molecule is smaller। ठीक है। Arrange the following in increasing order: bond length and bond dissociation energy. Let me tell you, N2 has bond order 3, N2 positive has 2.5, N2 negative has 2.5। तो इन दोनों की बॉन्ड लेंथ सेम होगी और इसकी बॉन्ड लेंथ छोटी होगी, क्योंकि जितना ज्यादा बॉन्ड ऑर्डर होता है उतनी स्मॉल बॉन्ड लेंथ होती है, और जितना ज्यादा बॉन्ड ऑर्डर होता है उतनी ज्यादा बॉन्ड एनर्जी होती है। तो सबसे ज्यादा बॉन्ड एनर्जी है N2 की, फिर N2 पॉजिटिव इक्वल टू N2 नेगेटिव। ये होगी आपकी बॉन्ड ऑर्डर और बॉन्ड एनर्जी। बॉन्ड लेंथ में उल्टा हो जाएगा। ठीक है। ये देखो यहाँ लेस देन का निशान आएगा, उसमें N2 पॉजिटिव N2 नेगेटिव N2 पॉजिटिव इक्वल हो जाएगी, और N2 का बॉन्ड लेंथ सबसे छोटी हो जाएगी। ठीक है। ये आ जाएगा। ऑल द क्वेश्चंस आर डन आई थिंक। लेट मी चेक। यस, द वेरी इंपॉर्टेंट क्वेश्चंस वी हैव डिस्कस्ड ऑफ चैप्टर केमिकल बॉन्डिंग ऑल्सो। ये बहुत इंपॉर्टेंट क्वेश्चन है, इसको लर्न कर लो अच्छे से। आप किसी भी स्कूल में पढ़ते हैं इसमें से आता ही है, किसी भी स्कूल में पढ़ते हैं। दीज आर द वेरी इंपॉर्टेंट क्वेश्चंस, इनको समझ लो। एंड ये भी हो सकता है कि मतलब थोड़ा सा क्वेश्चन चेंज होके आ जाए, थोड़ा सा अवेयर रहना है आपको। ठीक है। सो ऑल द बेस्ट। लेकिन हार्ड वर्क का कोई सब्स्टिट्यूट नहीं होता है। जब भी आप पढ़ने बैठेंगे मेडिटेशन जरूर करेंगे और एफर्मेशंस देंगे कि यस आई एम सुपर इंटेलिजेंट, मुझे सब कुछ आता है। ठीक है। तो पॉजिटिव सोचना है एग्जाम में भी, और कुछ नहीं आता तो आराम से आईज क्लोज करके पूछोगे तो अपने माइंड से आपको याद आ जाएगा। ठीक है। ऑल द बेस्ट।